So before we can start getting into any chemistry, understanding chemical reactions and so on, we actually need to have a foundation of chemistry knowledge, understanding the particles that make up the world around us, the matter that makes up you and me, the desk you're sitting at, the chair you're sitting on, the computer you're working on, that sort of thing. So we need to have an understanding of what this stuff, matter, is, the stuff that we can actually see, touch, smell, and so on. When we're being assessed on our understanding of chemistry, and that's the unit we're doing, is the acids and bases unit, there's three main things we need to make sure we cover in our answers, in our longer answers, to get those higher grades, those merits and excellences. First of all, we should be talking about our observations. What did we see happen or feel happen? Did it get hotter? Did it get colder? Did it change colour? And if so, what colour was it? And what colour did it end up? Did it catch fire? Just those basic observations that are obviously true. So I saw it go from green to yellow. That would be an observation. It gave off heat. That's an observation. If I can link those observations to the particles involved, so for example, talking about the ions or the atoms or the molecules and what's happened to those. For example, if you boil, we'll do something really simple. If we boil water, the particles are speeding up and moving away from each other. That's why it turns from a liquid to a gas. Okay, so our observation is that the water bubbled and the volume went down and there was steam rising off it. Our particles explanation would say that the heat energy made the particles move faster and it broke the bond between them for some of them, and they escaped as steam, turning into gas. So there, I've explained it. To really discuss it, I'd have to be able to show it using an equation and or a calculation. So that's about writing a chemistry equation for what we observed and the particles involved. If I can link all three of these together in an answer, I'm doing chemistry, which means I'm going to get merits and excellences if what I've said in these three areas is correct. But before I can really explore the particles, I need to know what particles, chemicals, matter are made up of. And last year, we should have looked at mixtures and pure substances. This year, we don't really look at the mixtures so much, except for after we react them, they turn into some pure substances. So I mix iron and sulfur together, it's a mixture, but then I'm going to do a chemical reaction on it to turn it into a pure substance called iron sulfide. So this is the side we're really focusing on, our pure substances. And pure substances can be classified into two things as well. We've got our elements and our compounds. And to start with, we're going to focus on elements because once we understand elements, understanding compounds becomes really easy. Because in here, we've got that thing called the periodic table of elements, and an understanding of that and how to use it as a tool. Read it a bit like a cheat sheet, and that's something I'm going to teach you how to do. Helps us understand both of these really, really well. So elements are things that are only made up of one type of atom. They can be just atoms on their own. So for example, all of our metals, iron, copper, magnesium, all of those things exist as atoms, and the electrons that are in the orbits around them create what's called the metallic bond between them. So they're effectively existing, living as atoms. We've also got things like neon. So the far right-hand side of our periodic table has got those things called the noble gases, and they just exist on their own, which means they're really hard to find. They're some of the most recent elements that we discovered because they exist as atoms. Other elements have been a bit easier to discover because they exist as molecules. Things like hydrogen, oxygen, those sorts of things, where more than one atom is bound together, joined together by what's usually a covalent bond, where they're sharing their electrons, so they have to hang around together because they're actually sharing something with each other. They can't leave each other unless we do a chemical reaction. So we have two types of elements, the molecules and the atoms. For this year, there are more than this. For this year, we can split our compounds into two groups as well. Our molecules and our ionic things. So our ionic compounds and our molecular compounds. Our ionics is a metal with a non-metal, or a metal with a group of non-metals. So something like sodium hydroxide, copper carbonate, those sorts of things. If the first word is a metal, then it's almost certainly ionic. If it's not, like water, which is H2O, or ammonia, NH3, when it's all non-metals, stuff on the right-hand side of the periodic table, then it's a molecule. Again, like the elemental molecules, the ones that are elements, they're sharing electrons and have to hang out together. So once we know these definitions and maybe can represent at least these three, that's why I put them down on the same line, with little pictures, little diagrams to represent them, by the way, that representation sort of covers these two a little bit. Then I can use these things to explain what we observe about them. For example, why oxygen is a gas, why oxygen reacts with metals so well, that sort of thing. So we can start to use our foundation chemistry to explain chemical reactions.